Hi, in this video we are going to discuss about our implementation of Twitter application using Erlang's distribution model and WebSocket servers. Our architecture as shown in the diagram consists of four different components. The first being the simulator. Simulator is our API interface with which we test our implementation. Each Erlang Twitter user are represented using Erlang's processes as shown here, and each process has different features such as register, waiting, follow, etc. Each of these processes talk to the WebSocket server using the Gun WebSocket client. We use the Gun framework for the implementation of WebSocket client, and the WebSocket client talks to the WebSocket server for posting tweets, for registering users, and all of those functionalities. In case of error, the WebSocket server will respond back with the error code and the reason for the error, or it will send the appropriate API response for each of the APIs back to the WebSocket client. The client will send back the response to the Twitter user processes. So this is the high-level architecture of our implementation. Now let's go to the execution of our program. I've already started the program using the make command. As you can see, our engine is initialized. We can check that the required processors are running quickly. We can see that the Cowboy server is running, and you can also see that the Twitter backend server is running, and the engine server is running, and the gun server is also running. So now let's start with the execution. First, we need to start the simulator as it is our interface here. Let us start. Then we can register a bunch of users here. As you can see, initially, when the user is registered, they don't have any of the states, which we can see by requesting for the engine state. So this is the state of the engine. This is represented using one of our data records. This is the engine state. It contains the tweets, hashtags, and users. Next, let's go ahead and post a tweet for a user. We give the username, and that to save time, we have some pre-written tweets. The tweet is posted. The server has responded with the API result. Let's post a couple more tweets for the users as well. Yes, it is posted successfully. As you can see, the server has returned by fetching the right hashtags and the mentions from the tweet content. So these are populated in the engine state at the appropriate fields, and return back when queried. Now we can request a user to follow another user. This is done by calling the subscribe API. We can do, we can give this by providing the username and providing the list of username that the user want to follow, stack, and Surya. Right, so this should do it. User Shreya, this is a response from the server. Now, when the user connects, we call the method called user feed that will fetch the tweets from the users following and hashtags list. So now, if you want the feed of user Shreya, you can just fetch it from passing user Shreya. And yes, so when for the user Shreya, the user feed will return the tweets of users Zach and Zurian, since Shreya is following Zach and Zurian, and it will have all the details for the tweets. So that's it with respect to the execution. Now let's look at the implementation. The key components of our implementation consists of the data records, which is stored in the engine state. Each of the data records has uh, certain key fields that represent each of the entities, and then the key engine component is this engine process that runs in the uh, WebSocket uh, WebSocket server during the start. We start the engine here and it runs until the WebSocket server terminates. And then we have the handler which handles the API for API call of each for each of the uh, API request. We get the uh, JSON request body as a binary and then unpack them using message pack and then use them for triggering appropriate callbacks. And then we have the simulator which contains all the APIs that we can trigger from the terminal to perform the different operations. Then we have the Twitter user processor. Uh, this process represents a Twitter user and can and basically uh, talks to the gun server. So, like as we explained in the uh, architecture, that users use a gun client to talk to the WebSocket. So, yeah, the users send messages to the gun server and gets back the response to print them in the terminal, as we seen in the execution. So these are the different modules of our implementation. With this, we have reached the conclusion of our video. Thank you.